Hi, I'm Anthony, and today I'll be doing a short walkthrough through the integrated Arduino code needed to operate and control the entire test specimen setup. So this video will go through the program that will operate the Arduino, the LCD screen, the load cell, and the micro SD card module. So the first thing you want to do is open up your Arduino IDE, and that can be installed online and is available both on Mac and Windows. The next thing you want to do is connect your hardware to your software by clicking this box right here. And there's a variety of ways to connect, either through WLAN, which is your local Wi-Fi network, or through Bluetooth, or through USB modem, which is the physical connection. I always recommend using the USB modem connection just because it's the most stable and it's prone to the least amount of disconnections and interruptions. So whatever Arduino device you have, whether that's an Uno or a Nano, it should pop up here, and you click it, and it will simply connect. I don't have one connected right now, so that's why it says no connection, but it's as easy as just going through that menu and clicking that. The next thing you want to do is install your necessary libraries. So you want to include the Arduino library, the liquid crystal library for the LCD screen, the HX711 library for your load cell/load cell amplifier, and the SD library for the micro SD card module. Now, if you don't have one of these libraries installed, when you try to compile and upload your code, you'll get an error. For example, the HX711 library is a common one that people don't have. But this is an easy fix. You can just go over to here and search up HX711 to install a library. The next thing you want to do is you want to define your pin connections. So here I've defined a number of connections for the encoder and optocouplers, the micro SD, as well as the load cell. And then this right here is the calibration factor for the load cell, which should be done in a separate program to the system. Then you want to declare your hardware, so the liquid crystal for the LCD screen, the HX711 for the load cell scale, and the SD card module as well. Now, these below are some helper functions. Now, these aren't strictly necessary to build the program that operates and runs the system, but I believe it makes the development process a lot easier, and it makes your code look a lot cleaner, having things kind of decoupled and into separate helper functions. So for example, this helper function right here called list directory, it allows you to list the files actually on the SD card. So when you run this function, it actually will list them out on your serial monitor. This way you don't have to take your SD card out and plug it directly into your computer. You can actually still do it with your regular setup and view the files on the SD card directly on the serial monitor. Now, this is beneficial because not only does it save time, but you don't want to be running your setup for 1 hour, 2 hours, 3 hours and realize that data is not actually being logged to the SD file. So this way you can check if an SD file that you created is actually listed when you list all the contents of the SD card. Next is clear serial monitor. So you're probably gonna be using your serial monitor for a lot, whether that's viewing data or debugging, and it can get cluttered. So clear serial monitor is a way to kind of just clear it and start fresh. Now, read serial string is a way that the serial monitor can take inputs and the program can get that input. So for example, in this bar right here, you can include stuff in your program that will actually respond to certain things typed inside the bar. So you can program your code to perhaps stop a trial if you type in pause or stop or something like that. Now, this formatted time helper function helps, as the title indicates, format time. So by default, Arduino counts time in milliseconds, and this isn't really intuitive to us. So in order to know exactly how long how long a shaft has been running for, this function can easily be used to convert that milliseconds to a more readable time format. In my case, I just did hours, minutes, and seconds. Now, format number is another helper function I created, and this allows you to convert the number of cycles into thousands. So for example, they're going to be, since the average number of cycles per rotation, the average number of rotations per second is about 16 to 17. That means there will be thousands or tens of thousands, hundreds of thousands of full cycles completed within one trial. And if you want to view it on the LCD screen, sometimes it takes up a lot of space if it's a really long number. So this helper function just simply reformats it to 13K or 14K and does all the rounding and string manipulation for you. Now let's go into declaring the actual variables. So these two right here are for the current reading of the load cell and the last reading of the load cell. These two right here are for the total number of light pulses that go through the notches on the encoders. In these two variables right here, cycle D and cycle I, D and I are just the name of my encoders, are the number of complete cycles completed over the course of the entire test. And I'll get into this a bit later, but these two variables, the number of completed cycles, is basically easily calculated from the number of total light pulses the encoder has experienced. Now, RPS is the rotations per second, so that's going to be the speed at which the shaft is rotating, and this could differ based on the load that's actually placed on the shaft. And then there's some other variables as well, such as ones to keep track of time, the data file to which the data is logged to, and other things like that. This helper function right here, display weight, is a way to display the current reading on the load cell on the LCD screen. Now let's get into the more important section of the code, the void setup and the void loop, which is the main parts of the program that will operate the system. So first, I always like to print something on the serial monitor so I know exactly where in the program I'm at. So I print program loading so I know that the program is still being set up, is in this setup function, and is being initialized. And then this right here is very important to initialize the micro SD card. This code is important because it helps you know if your software is correctly recognizing your SD card. Now, the SD card module is unfortunately a bit fragile and a bit finicky, so you're likely sometimes going to experience card failure not present. That's a common pitfall. This code helps you realize if that's a software issue or a hardware issue. If your card is saying card failed or not present, a solution could be as simple as taking the SD card out and putting it back in, or it could be, sometimes you have to plug the SD card into your computer and actually reformat it to another, to one that the Arduino can recognize, an FAT file format, and other times it's a software issue. So this section of code helps you realize what issue is that. Now, this portion of the code initializes the inputs of the rotary encoders, and here I just print a simple little welcome to specimen testing on the LCD screen to know that the LCD screen is operating as intended. And then here I'm actually opening a data file because it's not enough to just initialize the SD card. You actually have to initialize a file on the SD card. So this section of the code right here either opens the name of this data file. Now data file is a variable, remember, that we declared up here. So this is the actual name of the file, realtest.txt. And if it recognizes that file, it will say writing to realtest.txt, and if there's an error opening the file, then it will state an error. So I print this out on the serial monitor so I know if my data is actually being logged or not. If there's an error opening it, you want to know, because you don't want to just be running your test. Like I said before, you don't want to be running your test for 4 hours, 5 hours, and come back to see that none of the data was actually logged. So this way, you know if the file was instantiated correctly. Now, it's important to know that this will either create a file if the name of that data file, realtest.txt, already exists on the micro SD card, and if it doesn't, it will actually create that file for you. Now, these two lines are really important because they help you track the total number of light pulses that go through those notches on the encoder. So this function, attach interrupt, is used to attach an interrupt to a specific pin of the Arduino. In this case, we're using it on the pins that are associated with the two encoders. So an interrupt is a signal that causes the processor to temporarily stop what it's doing and execute a particular function known as an ISR. So this is the function that will be executed. And ISR just stands for interrupt service routine. So once this ISR is executed, the process resumes the previous task. So in this case, every time there's a change detected on this pin, this function will be executed. Now, what is this function? This function is the ones I skipped earlier, and it simply just increments the total number of light pulses on the encoder for each encoder, if you have two. Now, you might be wondering, why do you have to do it like this? Why can't you just somewhere in your loop code type, number like total number of light pulses plus plus and just increment them by one on every iteration of the loop? The reason you can't do that is because if you think about it, if the shaft is spinning at around 16 to 17 cycles per second, and there's about 40 light pulses or light blockages per full cycle of the encoder, there's going to be thousands to millions of total number of light pulses. It's actually changing so fast. There's so many increments that is actually updating faster than the code can handle. So if you put it in your loop cycle, it would have to execute the rest of the loop before it goes back. So it is actually changing faster than the processor can handle. So this way, if you do an interrupt signal, it will stop whatever the program is currently doing, execute this function, which just increments and counts accurately the number of light pulses, and then it'll go back to whatever it was doing before. So these two lines are really important to accurately count the number of complete cycles of the shaft. And then finally, the last part of the setup is just instantiating your load cell. I called it scale. So this just handles load cell and initializes the pins as well as sets the calibration factor, and it also clears it. Now to go into the loop code. So I am going into the perform new trial code within the loop. So within this function, first, these two lines keep track of the time elapsed since the beginning of the trial. And then I'm reading the current state of the encoders. And then here is where I'm actually calculating the total number of completed cycles over the course of the test. So this is as simple as just dividing the total number of light pulses on the encoder, like we talked about before, by 40. And 40 is significant because if you actually take your encoder and count the number of notches, there will be 40 light pulses or not light pulses that are counted, which indicates a full cycle. And this actually represents the number of completed cycles, so that's why it's a floor division rather than a regular division or a ceiling division. Now, for every second, we're going to record data. So this is what this if loop is doing. And I'm going to calculate the rotations per second by looking at the number of cycles completed within the past second. And that's simple, is just doing the number of cycles now minus the number of cycles completed in the last second. Then we're going to write formatted data to the SD card. So we're going to open that same file and make sure we're file writing. And then we're going to write important data points like time elapsed, total number of cycles, rotation speed, and weight. So the current weight that's actually the current weight or load that's currently on the shaft. And then we're also going to print to our serial monitor. So why do you want to print to both the SD file and the serial monitor? I think this is a great debugging technique because it's great to actually see the data in front of you and to make sure and validate that everything is as it seems, right? The time is being recorded correctly, the number of cycles or the total number of completed cycles is being recorded correctly, the weight's being recorded correctly, the rotation speed. So as you can see here, my data is actually printing to the serial monitor when I ran it. And this way I know, okay, it's actually logging data every second. It's calculating the total number of cycles correctly. The rotation speed is fluctuating between 15 and 16, and the weight is consistent at 1 kilograms. So this is just a great way to double check that, yeah, my data looks right. For example, if you saw that your number of completed cycles is decreasing for some reason, obviously you have a software issue because the total number of cycles can't decrease. And then you want to update your time, just to the last update time to the current time. And then here we're displaying some important data on the LCD screen. Now, since the LCD screen is just 2 rows of 16, it can't fit all this data, so you have to choose what you want displayed on the LCD screen. So for my case, I just chose the number of completed cycles, the time elapsed, as well as time elapsed right here, as well as the weight, which it is doing in this function. So that basically concludes the loop. There is one more helper function down here called view past data. And this one I found helpful for viewing the actual data on the SD card. So after your trial is done, you want to obviously view the data and make sure it was all recorded correctly. So you can either take your SD card out and plug it into an adapter and plug it into your computer, which is not that much work, but it can get a bit tedious. So this is just a software function that actually allows you to view data actually on your serial monitor. So it allows you to type in the file name and then actually view that data being printed on your serial monitor. So that just saves you a bit of work, and you don't have to kind of dismantle your hardware to view that data. You can do so directly on your serial monitor. Now, that basically concludes this short walkthrough. And I think the last thing I'll say is in terms of debugging, this is a fairly long piece of code, like 300, 400 lines. Not everything is necessary in my program, but while you're developing, I think it's really beneficial to use the serial monitor to your advantage. Print out what state of the code you're at, print out variable names, print out variable values. This way, it helps you narrow down what portion of the code actually has an error. If something doesn't compile, or if something isn't being recorded correctly, logged correctly, it's really hard to figure out exactly what part of your code is messing up unless you actually view variables, print stuff out on your serial monitor. So by doing that, it saves you a lot of time. It helps you develop the code quicker, and then you get to do the fun part of actually starting to run some experiments and break some 3D printed shafts and analyze the data according to the stuff you learned in class. So thank you.